Mars, often called the red planet due to its reddish appearance, is the fourth planet from the Sun and the second smallest planet in the solar system. It has been a subject of fascination for centuries, and extensive study by space missions has revealed many of its secrets. Here's everything known about Mars. Mars has a diameter of about 6,779 kilometers, 4,212 miles, making it about half the size of Earth. Its mass is 6.42 times 10 to the power of 23 kilograms, about 11% that of Earth. Mars has a density of 3.93 grams per cubic centimeter, which is lower than Earth's density due to its smaller core and lower metal content. The surface gravity on Mars is 3.71 meters per square second, or about 38% of Earth's gravity. This means you would weigh much less on Mars than on Earth. Temperatures on Mars vary widely, from about -143 degrees Celsius, -225 degrees Fahrenheit at the poles during winter to 35 degrees Celsius, 95 degrees Fahrenheit at the equator during summer. However, the average temperature is around -63 degrees Celsius, -81 degrees Fahrenheit. The planet's reddish appearance is due to iron oxide, rust, on its surface. Mars orbits the Sun at an average distance of 227.9 million kilometers, 141.6 million miles, which is about 1.5 times the distance from the Earth to the Sun. Mars takes 687 Earth days to complete one orbit around the Sun, making a Martian year nearly twice as long as an Earth year. A day on Mars, a sol, lasts 24.6 hours, only slightly longer than an Earth day. Mars is tilted at an angle of 25.2 degrees, similar to Earth's tilt of 23.5 degrees. This axial tilt gives Mars seasons similar to Earth's, but they last about twice as long due to Mars' longer year. Mars' atmosphere is thin, consisting mainly of carbon dioxide, 95.3%, with smaller amounts of nitrogen, 2.7%, argon, 1.6%, oxygen, 0.13%, and water vapor, 0.03%. The atmospheric pressure on Mars is very low, about 0.6% of Earth's pressure at sea level, equivalent to standing at an altitude of 30 kilometers, 19 miles, above Earth's surface. Winds on Mars can reach speeds of up to 60 miles per hour, and the planet experiences global dust storms, which can cover the entire planet for weeks or even months. These storms are the largest in the solar system. While liquid water can't exist for long on the Martian surface due to the low pressure, water vapor is present in the atmosphere, and frozen water is found at the poles and beneath the surface. Mars has a diverse and dramatic landscape with a range of geological features, including Olympus Mons, the largest volcano in the solar system, stands at 21.9 kilometers, 13.6 miles, high, nearly 3 times the height of Mount Everest. Valles Marineris, a canyon system that stretches over 4,000 kilometers, 2,500 miles, and is up to 7 kilometers, 4.3 miles, deep, is one of the largest canyon systems in the solar system. Mars has numerous impact craters, the largest of which is Hellas Planitia, a basin over 2,300 kilometers, 1,430 miles, wide and 7 kilometers, 4.3 miles, deep. Mars has permanent polar ice caps made of frozen water and dry ice, solid carbon dioxide. During Martian summers, the carbon dioxide sublimates, leaving behind water ice. Mars is thought to have a layered internal structure similar to Earth. The Martian crust is thought to be about 50 kilometers, 31 miles, thick. Unlike Earth, Mars does not have tectonic plates, but evidence suggests past volcanic activity. Below the crust, the mantle is composed of silicate minerals and extends to about 1,560 kilometers, 969 miles, below the surface. Mars is believed to have a partially molten core made primarily of iron, nickel, and sulfur. The core is likely about 1,700 kilometers, 1,056 miles, in radius, but unlike Earth's core, it does not generate a strong magnetic field. Mars has shown evidence of past water flow, although the surface is currently dry. Key findings include features like outflow channels and river valleys suggest that liquid water once flowed on the Martian surface. Mars has minerals that form in the presence of water, like clay, hematite, and sulfates. Frozen water exists at both poles, and there is likely a significant amount of water ice beneath the surface at mid-latitudes. Dark streaks observed on Martian slopes during warm seasons have been hypothesized to result from salty liquid water, although this remains under investigation. Mars lacks a global magnetic field, but regions of the crust are magnetized, indicating that Mars may have had a magnetic field in the past, which could have protected its atmosphere from being stripped away by the solar wind. Mars has two small moons. Phobos, the larger and closer of the two moons, Phobos is irregular in shape and orbits Mars at a distance of only 6,000 kilometers, 3,700 miles. It is slowly spiraling toward Mars and is expected to crash into the planet or break apart in about 50 million years. Deimos is smaller and farther from Mars, orbiting at about 20,000 kilometers, 12,400 miles. Both moons are likely captured asteroids from the asteroid belt. Mars has been a major focus of planetary exploration due to its potential for past or present life. Many spacecraft have been sent to Mars, including orbiters like Mars Odyssey and Mars Reconnaissance Orbiter, landers like Viking and InSight, and rovers like Spirit, Opportunity, Curiosity, and Perseverance. These missions have provided extensive data on Mars geology, atmosphere, and potential for habitability. While no humans have visited Mars yet, NASA and private companies like SpaceX are working on missions to send humans to Mars within the next few decades. The search for life on Mars is a major focus of current and future exploration. While no definitive evidence of life has been found, there are intriguing signs. The Curiosity rover has detected organic molecules, which are the building blocks of life, in Martian rocks. The detection of methane in Mars' atmosphere has been puzzling. Methane can be produced by both biological and geological processes, and its seasonal variation suggests an active source beneath the surface. Liquid water may exist under Mars' surface, particularly beneath the polar ice caps, which could be a habitat for microbial life. Some scientists and visionaries have proposed terraforming Mars to make it more Earth-like, by thickening its atmosphere and raising the temperature to support liquid water. While this is purely speculative and would take centuries or longer with current technology, it remains a popular topic in science fiction. Mars is a fascinating and dynamic planet with a rich history of geological activity and possible habitability. While its current conditions are harsh, evidence suggests that it was once more Earth-like, with liquid water on its surface. Ongoing and future missions aim to answer fundamental questions about Mars' past, the potential for life, and its suitability as a destination for human exploration.